Hello, everyone. Today we will explore the potential of ChatGPT with ESP32, a powerful combination that can take IoT devices to the next level. The ESP32 is a new generation AIoT development platform released by Espressif Systems. I will show the development process and effect demonstration of a voice-controlled chatbot that combines ESP32 and OpenAI API. This video was structured into 3 primary sections, each covering essential aspects of the big project. The first section delves into steps to integrate component that outline the steps involved in building the project from scratch. The second section is a usage example, providing more details on its functionalities. The final section, Real Demo, shows the specific application of ESP32 with ChatGPT in real life. Without further ado, let's begin. To begin with, we need to set up the environment. I am using Linux environment and set up ESP32 from GitHub. First, we clone the ESP32 from the official GitHub repository. After that, we can proceed with the installation by the guidelines provided in the official documentation. You can also install the correct ESP32 version in many other ways following the official ESP32 guide. The related links have been posted in the description. In order to build this project, we need to export it in the terminal environment at ESP32. When the installation is successful, we can proceed to the integration of OpenAI component. The component registry is a treasure where you can find the desired components offered by Espressif or other ESP developers. Here, we can simply type in the keywords OpenAI into the search bar. There's no need for a complex process, it's actually quite straightforward. Then just copy and paste the command. The OpenAI component will be added through the .yml file. When you build the project successfully, it will be automatically downloaded and managed within your project. Now we have OpenAI component in our project. Let's do some coding. First, we need to write a code to connect our ESP with Wi-Fi. Espressif already provide an example code for that purpose. Let's go and explore that code and reuse that within our sample project. Click ESP32 examples, Wi-Fi, getting started, and station in turn. Then you can explore this code. I'm not going into the details of this code here. What we are going to do is going to copy this main file code into our project. I made a new file name app.wifi.c and copy this code into it. We don't need app main function in this app.wifi.c, so I cut it and replaced our app main function in our main.c file. To tell the compiler about app.wifi.c file, we need to update makelists.txt file. If you closely look at the code in app_wifi.c, there are several config parameters are present. To give values to these parameters, we need to add a config.projbuild file in our project and copy the code from ESP32 Wi-Fi example config.projbuild to there. Lastly, we need include relevant headers in main.c file. Also add tag for ESP log and declare Wi-Fi_init_sta function, so that linker will know about this function. After all these steps, the project builds successfully. Next, we can start coding OpenAI in our project. Here I am coding ChatGPT API. We can use the ESP IoT solution documents or directly look into the code or leverage the OpenAI.h header file. Let's create a function with a name chat response that takes a pointer to a constant character array as input. The function does not return anything. Set a pointer OpenAI to the OpenAI_T data structure. And initialize it by calling the OpenAI create function with the API key provided by config OpenAI API key. Further, let's create a pointer chat completion to the OpenAI_chat completion_t data structure. And initialized it by calling the chat create function of the OpenAI object. This function prepares the object for chat completions. Now set the model of the chat completion object to GPT-3.5 Turbo. This model is a specific version of the GPT-3.5 architecture provided by OpenAI. Similarly, set the tokens temperature, stop, presence penalty, frequent penalty, user if any. Temperature means what sampling temperature to use, between 0 and 2. Higher values like 0.8 will make the output more random, while lower values like 0.2 will make it more focused and deterministic. For more details, please refer to official OpenAI API reference. Then, send the input text to the OpenAI API for processing. The message function of chat completion object is called among input text as the question, and false indicates it is not a system message. Finally, retrieve the response after parsing the data using getData function on result pointer. Later, print out the input text as a question, the response as a response on the terminal. After typing error removing, all the code will look like this. After this, we can build the project and flash it to the ESP SoC. Wait the ESP to connect to the Wi-Fi. We can finally get the answer to our question. Certainly. By leveraging the components and demos provided by Espressif, you can build more complex and interesting apps. For instance, you can create a voice chatbot as an example. In addition, you can consider using Squalling Studio to design your app's user interface. And then export the project to utilize the lightweight LV graphics library for implementation. Here is an example code showcasing how to utilize ESPbox in combination with OpenAI to create a voice-based chatbot. The demo code is available on the ESPbox GitHub repository maintained by Espressif. Finally, let's enjoy our creation and feel the power of OpenAI and ESPbox 3 together.
Hi ESP. Who are you?
About your question, please wait a moment. I am AI language model developed by OpenAI. I am designed to assist with answering questions and engaging in conversation on a wide range of topics. How can I help you today?
Hi ESP. How far do you think AI will go?
About your question, please wait a moment. AI has the potential to go very far and has already made significant advancements in various fields. However, the ultimate extent of AI's capabilities
That's all for today. Thank you for watching. If you are interested in this video, please follow our account to get more information. The comments section has provided a list of additional sources of information that you can explore to deepen your knowledge and understanding of the project. Thanks, bye.